Hello, and welcome to part 7 of the LinuxKI video series. In this session, we continue with the LinuxKI text-based reports with the CPU and RunQ analysis report. The table here describes the various reports generated by the KI all script and the reports covered so far. The CPU and RunQ analysis report is in the text-based file starting with KI RunQ. We'll discuss this report next. The CPU and RunQ analysis report gives us detailed statistics on CPU usage and CPU wait times, which is the time spent on the CPU run queues. A CPU core can execute in one of three states: in kernel or system code, user or application code, or it can be idle. However, the CPU core may also process either a hard or soft interrupt while in one of the three states. The global CPU counters provides the time in seconds each CPU core spent in each state. LinuxKI can also collect advanced CPU statistics when the RunKI script is executed with the -R option. The CPU statistics are also presented in percentages as well. The per node CPU counters provide the same details, but sums up the totals for each processor socket, also called a NUMA node. This can be helpful in determining if one NUMA node is near 100%, while other NUMA nodes have plenty of CPU available. There is also detailed information on the interrupts. Note that the interrupt elapsed time and the average time per interrupt are reported along with the interrupt count. The interrupt statistics are also broken down for each CPU core. The hard IRQ statistics are listed first, and then followed by the soft IRQ statistics. There is also processor information on C states and P states. Note the P state information does not include turbostat frequency speeds and are only listed when the OS changes the frequency. Unique to LinuxKI, the Hyperthread statistics shows how often Hyperthread sibling pairs are both idle, both busy, or one logical core is busy while the other logical core is idle. Transaction response times do tend to degrade as both logical cores become busy. The RunQ latency statistics provide the average time that a task waits for CPU when it's ready to run. As the CPU cores get busier, the RunQ latencies will increase. The report shows the top tasks that waited for CPU, followed by the top tasks that are executing CPU. And finally, the report shows the top tasks consuming CPU in kernel or system code time. For additional details on the CPU RunQ analysis and other reports, refer to the LinuxKI Masterclass documentation on the LinuxKI wiki page. Thank you for your time and have a great day.